All right. 2, 3. We're going to split this up as day 1 and day 2. You can see by the learning target here that it's about long division and synthetic division, okay, which comparing polynomials, as a quotient comes up all the time in Precalc, right? What it really gets to is it allows you to compare the rate at which two functions are changing, okay, relative to each other, something we're very often interested in. Two different processes to do it, two different cases when it's appropriate. The first day I'll show you some long division, 4 examples. And then the third day I think there's like 3 with synthetic division, which is kind of like a little bit faster method to do it. The trade-off is it can't always be used. But that's kind of where these lessons are headed in section 3. Long division and then synthetic. All right, here we have our first example here. I want to be clear on this one. The polynomial we're dividing by is just a little line, but it's down at the bottom of a fraction technically because it's what's being divided by. So I'm going to make it clear in this whole problem that if I'm looking at these two polynomials as a ratio, I have a restricted domain such that x can't be 2. Okay? If I put that on the bottom, I would get 0 on the bottom of a fraction, which I don't want. Okay? All right. Now, the first step is probably the trickiest in the whole process. I got to pick a term that's going to go up top. Okay? Here's my goal. I'm looking at the 6x to the third, and I need to select something to go on top so that when I multiply it by x, it's going to cancel with 6x cubed. Okay? Now I'll choose this one for you because it's one of those things that even if you took some time, I'm not, with how new the idea is, I'm not convinced you'd get it quickly. Notice how I'm lining this up over the squared term because I picked a squared term. The one we're looking for is 6x squared. If I multiply that by x, I get 6x cubed. Okay? Now, to continue the process, I have to take 6x squared and multiply it by -2. And I get -12x squared. Okay? Again, that's from 6x squared times -2. Those two terms are going to cancel. I knew they would. I picked the term on the top so that they would. These two won't. Careful with the subtraction. It's a little bit tricky. It comes out to be -7x squared. And when you bring down the next term, which you should always do, you can now think of it in the sense that we have done one round of division. This one's going to take 3. You're going to see on all the examples in this lesson 2 or 3. On your homework, maybe one snuck in there where there's 4 rounds. I doubt it. Maybe. I don't know. 5 or more rounds. Geez, that'd be pretty mean. I doubt it. I went through and picked ones that I thought were kind of appropriate for us. But the reason we say that's a round of synthetic division is we now go back and we basically start it over. I need to go back up to the top and pick a term, except now what I need to get down here is -7x squared. Okay? Well, the term I need up here is -7x. Notice it's lined up over 16x. Make sure that you're, consistent in doing that. -7x squared times x is the -7x cubed. times it by -2, and I get plus 14x. Of course, those are going to cancel. And there I get 2x. And then down comes my -4. Round 2 is now done. And I've pulled down the last term that was available, the -4, which means this is starting round number 3. And this is going to be the final round. Okay? Same deal, I go back up here, and the constant term I want at the end is 2, because 2 times x will give me 2x. 2 times -2, that's -4. Ooh, and a nice one to start. Nice remainder of 0, right? We'll have to deal with that in a couple examples here as to how do we deal with the remainder. This one doesn't have one, okay? Doesn't have one. So when I took that big cubic polynomial and divided it by x minus 2, I get 6x squared minus 7x plus 2. Keeping in mind, x still can't be 2. Okay? All right. Not a lot of variation in today's lesson, right? Long division is the theme. It's got a lot of steps. It can be a little tricky. So that's all we're going to do. You're going to see 4 examples, and if you're like, aren't we kind of doing the same thing? Yeah, we're kind of doing the same thing. Can take a little practice. Be clear on this one, x can't be -1, all right, because I'm dividing by x plus 1. Same place to start. I need a term to multiply by x, and right here, I need an x squared. Well, the term to do that is going to be x. X times x is x squared. X times 1 is just positive x. You're seeing this one's actually a little bit easier than the first one. And actually for the 4 that we're going to do, the one I gave you to start might actually be the toughest of the 4. Why did I do that? I don't know. Start with the toughest one, right? That's not the way we normally do it, but why not? Okay. Cancel. Here we're subtracting, and we get 2x. And look at here. Plus 5 comes down. And remember, you bring down that last term, that round of synthetic division is over, and the next one is going to be the last, right? This one is just 2 rounds, okay? I need to go up here, and the term I'm looking for is plus 2, because when I multiply it by x, I get minus 2x. Now 2 times 1 is plus 2. Now here we see a little different story. That'll cancel. The constant terms there don't. I get a 3, so what do I do with that? Well, head back up here. I have a remainder that needs to get tagged on to the end. Remainders are always relative to our divisor. Okay, so I have to put that on right at the end. X plus 2 plus 3 over x plus 1. Okay, you'll see on some of these I like to put there's no need for them typically, but I often like to put the remainder in parentheses just as it's a reminder that like x plus 2, that was our quotient, right? That's the polynomial that we got. We had a little bit left over. Like when we divide, that happens. Like when we divide with numbers, we see that all the time. You can have 2 that don't divide evenly into each other, and that's fine. Okay, you have something left over, right? Just really, really basic example. This has nothing to do with the problem. Really basic division problem, 9 divided by 4. There's your quotient. It goes in there twice. There's 1 left over, right? But we say it's 2 1/4 because we say that remainder is relative to what we divided by, right? That's true for numbers, right? For polynomials, we're still doing the same algorithm essentially for the division. We just have expressions that have variables. That's the only difference, but that remainder is still relative to what we divided by. Number 3, that doesn't look very long, but this one looks funny. Why does it look weird? Here's why. I want you to see one that's got a little gap in it. What we're dividing by is x minus 1, which means, of course, x can't be 1. Now as I write this out, I want you to see x cubed. But look at all this room that I left. There's no squared term. Well, I'm going to write it in anyway. Can you do that? Of course you can. The coefficient in front of x squared is just 0. That's why there's technically no squared term. But when we're doing long division, I want them there. It's really, really important to have them there. Okay? So I'd write it out like that. With the, all the terms should always be there. Remember, it's really, really important to kind of keep track of each of the steps that you're doing. Okay? Because I want to line up x squared, because that happens to be the first term that I'm going to choose, because I multiply it by x. And look at that. I get x cubed. Multiply it by negative 1. Because I'm still doing this whole subtraction thing, and if the squared term is there, well, it's just like the others, right? The squared term is there, it's got a 0 in front of it, which I can work with. That cancels, then I get 0 minus negative 1. Well, that's just positive x squared, and there's the next round of my division, right? Technically, we said once I take this next term, which is a 0x, okay, that's now when round 1 is done. Okay, now I'm moving on to round 2, and notice I haven't pulled the negative 1 down, so this isn't going to be it. This is going to have 3 rounds. Okay? Next term I'm picking is plus x. Right? And again, that's because x times x is x squared. Right? When I do this subtraction, I want those first 2 terms to cancel. Here, I don't know if that's going to happen. If it does, great. If it doesn't, I'm not expecting it to. And it doesn't. I get just positive x. Negative 1 comes down. Last term is going to be plus 1. Then you get x minus 1. Hey, it's another no remainder. And we get 0. Okay? X squared plus x plus 1, well, that would be our quotient. And one more. Okay? Looks terrible. It's actually not really all that bad. The difference here is what we're dividing by is a quadratic. Okay? If both polynomials that you're dealing with are a little bit longer, in the sense if they have more terms, it doesn't actually make the process longer. Like this one, you might look at both of these and like, wow, the polynomial, that we're dividing by is bigger. The one that we're dividing it into is a 4th degree. This is going to be like 12 rounds. So it actually ends up being 2. Okay, just 2 rounds. The starting place is the same. I need 2x to the 4th right here. Because I'm going to subtract those and I want those to cancel. Okay? I head all the way up over here. And this might be a part where when you're doing these on your own, you have to kind of pause and take a minute, right? Because that's a huge step. The term that we want up top is 2x squared, because I multiply that by x squared and I get 2x to the 4th. If we pick the wrong term right there, I mean, goodness, everything the rest of the way is going to be off. So don't proceed until you're sure you've got the right term up top. Now I got to multiply that by 2x. 2 times 2 is 4. X squared times x to the first is x cubed. And now I got to do 2x squared times negative 3, which would be minus 6x squared. Notice how particular I'm being to make sure all these terms are lined up. This whole process would be a disaster if they're not. Okay? Now this is kind of a nice one. That one cancels. Ooh, I wasn't expecting that one to, but that was kind of a bonus. Now remember, I'm multiplying by these 3 terms over here. So this one is a little bit different, and that's why this ends up being my second and final round, is I'm going to bring down the 3x. But I'm also going to bring down the minus 2. Okay? So when I multiply each term by, like the next term that I picked to go up top, I'm going to multiply it by x squared, then by 2x, and then by minus 3. I want each one to have a term that it lines up with. Again, what's driving the whole process is right here when I pick the term I'm going to put up top. I need x squared to go there. What's going to do that is plus 1. Alright, so when 1 times 2x will just be 2x. 1 times negative 3 is negative 3. The x squareds, of course, will cancel. These terms, however, won't. I'll be left with x plus 1, and that ends my second and final round of division. Okay? So what do we do with that x plus 1? Well, no worries. That's just our remainder. It's going to be kind of a bigger looking remainder here because I had x plus 1, but remember that's relative to what we divided by, which was x squared plus 2x minus 3. Kind of a big looking remainder there, which is fine, right? Your remainder, like whatever you're left over with when the process was done, relative to what you divided by, that's your remainder. Every single time, no matter if it's really simplified or not. So again, we divided those, we got 2x squared plus 1, and then that remainder.